Okay. I'm sharing my screen. I think my screen is visible. Okay. Yeah. So today we'll see about that dynamic CMOS logic. Okay. So what is this dynamic CMOS logic? So dynamic CMOS logic. So dynamic CMOS logic is nothing but you have like you have you have so if you see dynamic CMOS logic, you have VDD, and here you have gated CMOS, gated PMOS. Okay, this is nothing but you are giving a clock. Okay, that is a gated PMOS, and next you have this is a pull up. This is a pull down network. Pull down network as you have NMOS circuits. Okay, NMOS circuits, and there are some inputs are there for pull down network. There are some inputs. Let us take inputs are K inputs. Okay, inputs are K inputs. Yeah. So inputs are K inputs. Okay, K inputs, and output. So if you see the output is one more NMOS transistor will be there. Okay, so NMOS transistor will be there. For this NMOS transistor, again you are giving a clock. Okay, again you are giving a clock. Okay, so and here this is nothing but ground or VSS. Okay, so ground or VSS. Ground or VSS. Okay, so this is the basic structure of dynamic CMOS logic. Okay, dynamic CMOS logic. Okay, so normally so here this output, if you take this output, so this is the output. Okay, output is connected to that load capacitor. Output is connected to the load capacitor CL. Okay, so if you take that how many NMOS and how many PMOS are there, so that means you have only one PMOS. Okay, and if you take that NMOS you have so n inputs are there, no? So in pull down network n inputs are there, so you have like k inputs are there, so that means k plus again one more NMOS is there, so this is PMOS. Okay, these are like arrays of PMOS. You have k inputs, and clock is, this is NMOS. This is nothing but NMOS. Okay, so k plus 1 NMOS are there. Okay, so this is nothing but dynamic CMOS logic. So if you see the static CMOS, so we already see in the static CMOS. Static CMOS, what we have, like you have VDD. This is VDD. Okay, this is VDD, and next you have like uh, uh, so PMOS as pull up network, no? PMOS as pull up network. So PMOS as pull up network, that is nothing but you have uh, inputs. You have inputs. You have inputs. That those are nothing but K inputs. Okay, and next you have NMOS as pull down network. So here pull down network, NMOS as pull down network, and you have uh, let us take k inputs. Okay, here you have k inputs and here you have k inputs, and here you are taking the output, no? Here you are taking the output. Okay, so that means here you have PMOS as k PMOS. Okay, and NMOS, how many NMOSs are there? K NMOSs are there. Okay, so total, that means by using dynamic CMOS, we can decrease the size of the, means so we can decrease the number of PMOS. So see here. So if you see the dynamic CMOS, you have only one PMOS. Okay, you have only one PMOS, but in the static CMOS you have you have K CMOS. Okay, so but here you need to give it to the gated clock. Okay, so you need to you need to use two PMOS circuits, so that you need to give it to the gated clock. Okay, so this is about the dynamic CMOS. Okay, so I hope you understood. Any doubt in this? Shall I move forward? Yes.
Yes, sir.
Yeah. Next you see. Once again. So next, suppose if I want to draw the basic inverter for dynamic CMOS. Okay, basic. So if you see the basic inverter, for dynamic CMOS. Dynamic CMOS. Dynamic CMOS. So if you see the basic inverter, so how it will look like? So we are having one NMOS and one PMOS as a gated. You are giving it as a gated clock. Okay. So here this is nothing but a VDD, and this one is one PMOS. This one is one PMOS, and next this one is one NMOS. This one is one NMOS. Okay. So this is PMOS and this is NMOS. For PMOS, you are giving as a clock, and here you are giving the input voltage. Okay. So this is let us take VP is the input voltage, and next here for NMOS again you are giving as a clock. Giving as a clock. Okay. So for NMOS also you are giving as a clock, and this is nothing but ground RVSS. Okay, ground RVSS. So here where you are taking the output, here you are taking the output. Okay, here you are taking the output. So this output is given to the load capacitor, that is CL. Load capacitor CL. Okay. So if you want to draw this timing diagram for this basic inverter by using dynamic CMOS logic, so it will be like this. Suppose you take let us take this is nothing but a clock. Okay, so clock, how I can draw? So here I am drawing the clock. Okay, I am drawing the clock, and here I am drawing the input also. I am drawing the input. Okay, so let us take this is input. This is input, and I should get the output. Should get the output. Okay, so here this is output. Okay, so if you see this one, so like in the how the circuit will work means how the circuit so how the circuit works in two modes. Circuit works in two modes. Okay, so what are these modes? Two modes. These modes are nothing but you have prescale mode, and next you have evaluation mode. Prescale mode and evaluation mode. Okay, so prescale mode is nothing but it is done when clock is 0. Clock is 0. Okay, evaluation mode is nothing but it is done when clock is what? Clock is 1. Okay, there are two modes are there. One is prescale mode and evaluation mode. So prescale mode will be done when clock is 0, and evaluation mode will be done when clock is 1. Okay, so here I will draw the clock signal, and as well as based on these inputs and outputs. Okay, so clock signal will be so how it will look like. So clock signal, so here you are giving like 0 and 1. Okay, let us take this is clock signal. So clock signal, one second, drop this one. So I am drawing the clock signal. Let us take this is 0. Okay, so clock signal I am drawing. So here this is 0, and next clock becomes 1, and the clock becomes 0, then clock becomes 1. Okay, so this is the clock signal. Okay, so this is nothing but clock is 0, 1, and again clock 0 and clock 1. Okay, so this is the clock signal, and input also I am drawing. Okay, input also I am drawing. Okay, based on this clock signal I am drawing the input. So this is let us take the input. So two ones are there. Inputs are nothing but two ones. So two ones are the inputs, and two zeros are outputs. Inputs. Okay. So in inputs I am giving two ones and two zeros. Okay, two ones and two zeros. Okay. So how you are getting the output we will analyze. Okay. So I told you like two modes are there. No. So one is prescale mode and next one is evaluation mode. Okay, so in prescale mode you will not get any output. Okay, you will not get output, but in evaluation mode you will get input. Okay, so first when clock equal to 0, it will go in which mode? Means So I already told this is in 3 scale mode. When clock equal to 0, it will be operating in 3 scale mode. So when clock equal to 0, so when you are giving clock equal to 0, this will be what? On, and this will be what? You are giving input as 1. So this is also on, and here clock is 0 means this is what? Off. Okay. So this is so this will be off. So you are, for NMOS you are giving 0, no? One second. For NMOS you are giving input as 1. Okay. You are giving as input as 1. Okay. One second. You are giving input. Yeah. So if you see, you are giving input as 1, no? So input as 1 and clock as 0. Okay, clock as 0 means what? This will be on, and input as 1. So this will be on, and clock as 0 means what? This will be off. Okay, as this will be off, so what happens here? Whatever the VDD is there, that will come to the output. Whatever the VDD is there, that will come to the output. So here at this one, so that means here what you will get, so at a prescale mode, so here you will get VDD. Here you will get VDD. So you are not getting, means you are not getting the output. Just it will be like you are giving clock as what? So here clock as 0, input is 1, and clock as 0 you are giving. So based on that, this will be operated. Okay. And next, so when I am giving clock as 1, okay, when I am giving clock as 1, just I will change the color and I will try to analyze. Okay. So what clock as 1, what happens? This so this is 1, and anyway here input is 1, and clock as 1. Okay, what happens here? So this will be what? This will be off. PMOS will be off, and this will be on. This will be on, and next this one will be on. Okay, so this one will be on. So as the PMOS will be off, there is no connection from VDD to output. So that due to this charge, due to this capacitor, so what happens? There is a no connection between the VDD and output. So due to that, what happens? This will gradually decrease, gradually discharge through the capacitor. Through the capacitor is gradually discharged. So this is nothing but what? This is nothing but logic 0. Logic 0. So that means I told you in P-scale mode you are not getting any output. In evaluation mode only you are getting the output. Okay. In evaluation mode only you are getting the output. So that means it is acting as an inverter. So that means if you are giving input as 1, you are getting the output as what? 0. You are getting the output as 0. Okay. So this is for which condition? Input is 1 condition. So I need to check for 0 condition also. Okay. So I need to check for 0 condition. So if you see, so if for 0 condition, if you see, one second, okay. So if it is a 0 condition, so first prescale mode. Okay. First prescale. This is nothing but what? Prescale mode. When clock equal to 0, I need to give prescale mode. So prescale mode means what? Here I am giving clock equal to 0 and input equal to what? 0 and clock equal to 0. So in this case, what happens when clock equal to 0? This PMOS will be on or off. This will be on. Okay, and this you are giving 0 to the NMOS, so this will be off. This will be off, and here you are giving clock equal to 0 for NMOS. This will be off. Okay, so when this will be off, so there is a connection between VDD and output. Okay, so what happens again? This will charge capacitor. So capacitor has discharged in the evaluation mode. Again, what happens? It will charge. Again, it will charge. To which value? Again, it will charge to VDD. Again, it will charge to VDD. Okay, and after that, I'm giving clock as what? I'm giving clock as. Just I'll change the color so that you can understand. Okay, one second. Yes. So see here. So next what I am doing, I am giving clock as what? Clock as 1 and input as 0 only. Input as 0 only. And next I am giving the clock as 1. Okay. In this stage what happens? So when clock as 1, mm, one one second. So I'm giving the clock as 1. Okay, clock as 1 means what? This will be off, no? So this will be off. This will be off state, and input is 0. So input is 0 means what? This will be, this NMOS will be also input as what? Input I am giving as 1. No? So this will be on. This will be on, and here I am giving, sorry, here I am giving
Sir,
the
your input is 0, sir.
input is 0. Okay,
Yes,
input
sir.
is 0 means this is off. This is off. Input is 0 means this is off. And clock as what? Clock as what happens? Clock as I'm giving clock as what? 1, no? So 1
1.
means what? This
1.
will be on. This will be on. So what happens here? So basically, like basically it should discharge, but what happens, so here this will be like this will be off, okay, and this will be on, and this will be on, okay. So basically capacitor should discharge, but capacitor will be available in the VDD only, okay. Capacitor will be available in the VDD only, but what happens here, there will be a high impedance state will be occur, okay. So output, whatever the output is there, output will be available at high impedance, okay. So output is there at high impedance. High impedance, why it is high impedance? Here there is a open circuit. Due to this open circuit, so high impedance, when you call this high impedance, suppose like this connection is there, okay. So that means when there is open circuit, this is open is there, we can say that this is high impedance, okay. So that means if you are giving input as 0, you are getting the what? Logic 1 only, you are getting logic 1, okay. But what happens, this will be in which state? Means it will be in the high impedance state. It will be in the high impedance state, okay. Did you understood the operation of this dynamic CMOS logic?
Yes, sir.
Okay, shall I move
Yes,
forward?
sir.
Okay,
Okay,
so
sir.
that means here in the prescale mode you are not getting any input, okay, just it will come to the VDD. So in the evaluation mode only you are getting the output. So that means I can say that when clock equal to 1 only you are getting the output. It is acting as a inverter, no? So that means here you are giving first you are giving 1, you are getting the output as what? 0. So this capacitor is discharging. If you are giving input as 0, you are getting the output as what? VDD. But what is the disadvantage over here? Here output is, you are getting output, but there is high impedance will be there, okay. There will be high impedance, okay. So hope you understood. Next, so I need to write the advantages and disadvantages of this dynamic CMOS logic. What are the advantages? What are the advantages? Okay, so if you see the advantages, if you see the advantages, 1 second. Yes. If you see the advantages, so you are getting the output that is logic 1 at high voltage. That means at VDD you are getting, and logic that means output high you are getting at VDD, and output low you are getting at 0. See here. So that means if you see here, so this is nothing but output low. Output low you are getting at 0 voltage, and output high. Output high. So VOH. We sorry. VOH you are getting at what? VDD. You are getting it VDD, okay. So first advantage, VOH equal to what? VDD. VOH equal to VDD, and VOL equal to what? 0, okay. So it has maximum swing at output. It has maximum swing at output. Swing at output, okay. And you have ISS equal to 0. ISS equal to 0, and you have only, so we already seen, so we already compared dynamic dynamic CMOS and static CMOS. Dynamic CMOS has only how many PMOS you have? Just to give 5 minutes or 2 minutes. Once, yes. Okay. Sorry for the interruption. Okay. So you see, so for dynamic CMOS, you have how many PMOS? Only one PMOS. But for static CMOS, you have how many PMOS? K CMOS. So K inputs are there. Then you have K CMOS. I think my voice is audible. Okay. So K CMOS. Okay. So here, I can write the advantages of this. So it has only one PMOS. Okay. So it have only one PMOS means switching will be less compared to static CMOS. Switching will be less. Okay. So it has only one PMOS. It has only one PMOS. Okay, one PMOS. And next, we already seen no the size of the PMOS is greater than the size of the NMOS. Okay, so that means PMOS are more means the size of the total CMOS will be more. So here in the dynamic CMOS, so only one CMOS, one PMOS we are using. Okay, so that means size will be less. Okay, so it has faster switching speed. It has faster switching speed. Faster switching speed. Switching speed. Why faster switching speed? You have only one PMOS, no? So there is a faster switching speed will be there. Okay. And similarly, the circuit size is small. Circuit size is small. Why? Because you have only one PMOS circuit. So circuit size is small. Circuit size is small. Okay. And it has less capacitance. So as switching is more and capacitance switching also more. So that means it has less capacitance loading compared to static CMOS. It has it has less capacitance load, less capacitance loading loading compared to static CMOS. Static CMOS. Okay. So these are the advantages. Suppose if you take the disadvantage, there are some disadvantages also. Okay. So what are the disadvantages? We'll see. So what are the disadvantages? So disadvantages are nothing but so when it is a logic one, okay, it stages in high impedance mode, which is more affected by noise. So see here. So as I told you, like if it is logic one evaluation mode, so you are getting that means sorry, when the clock is 1 and when the input is 0, you are getting at logic 1 only. Okay, logic 1 only. But what is the disadvantage? So the output is in high impedance state. Okay, so when it is high impedance state, there is a there is a it will affect more noise. More noise. Okay, more noise means what? Unwanted signal will be added into this when it is at logic high. Okay, so noise is nothing but in electronics, if we call a noise, so that is nothing but not that normal noise. So that is nothing but what? Unwanted signals will be added. There will be like cross coupling like that. Okay, so that means here one of the disadvantage when output is logic 1, when output is logic 1, next it stages in what? It stages in it stays in high impedance state. High impedance state. Okay, high impedance state. And which is more affected with the noise. Okay, which is more affected with noise. Which is more affected with noise. So due to this high impedance, whatever the unwanted signals are there, that will be added when it is in logic high. Okay, and it requires precharging. It requires precharging. Precharging. Okay, and there are cascading issues also. Okay, so if you cascade this dynamic CMOS logic, there are cascading issues also that I will explain you. Cascading issues. Okay, and cascading issues, and there is also race problem also there. There is also some race problem will be there. Okay, there are some disadvantages, but means if you see the advantages, it is more advantage compared to the static CMOS. okay, compared to the static CMOS. Okay, so we'll compare. So what are these comparison of static CMOS and dynamic CMOS? Okay, so we'll compare. So basically, so till up to now we studied about what? We studied about static CMOS. Static CMOS, you have like pull up network as PMOS and pull down network as NMOS. Okay, so so if you compare, so comparison of static CMOS and dynamic CMOS, comparison of static CMOS, static CMOS and dynamic CMOS, dynamic CMOS. These advantages and disadvantages are fine, no? Do you understood? Give response.
Yes, sir.
Okay. Next. So I need to compare the static CMOS and dynamic CMOS. Okay. So if I want to compare the static CMOS and dynamic CMOS, this is a static CMOS, and next is dynamic CMOS, dynamic CMOS. So static CMOS and dynamic CMOS. So static CMOS and dynamic CMOS. So if you see the static CMOS, the basic diagram will be like this. Okay, pull up network as what? Pull up network as PMOS, and pull down network as what? Pull down network as NMOS. Okay, pull down network as NMOS. NMOS. You have like K inputs are there. K inputs are there. Here also K inputs are there. Okay, these are the K inputs. K inputs. Okay, for PMOS you have K inputs, for NMOS you have K inputs. So this is nothing but what? VDD, and this is ground. This is ground, and you are you are taking the output from where? Here. You are taking the output from here. Okay, so this is the basic structure of what? Static CMOS. So if you see the dynamic CMOS, you have you have one PMOS, you have one PMOS. Okay, you are giving gated clock for this one, and next this is VDD. This is VDD, and next you have pull down network. Pull down network as what? NMOS. Okay, pull down network as NMOS, and next you have this one is NMOS. For the NMOS you are giving the clock, gated clock, and here this is ground. So where you are taking the output, here you are taking the output, and this is nothing but you are giving a capacitor, load capacitor. Okay, so this is nothing but CL is nothing but load capacitor. Okay, so this is first difference based on the circuit diagram. Second difference, if you see, second difference, for static CMOS, how many NMOS are there? K NMOS. Okay, for how many PMOS are there? How many number of inputs, that many number of NMOS and PMOS will connect, no? So K PMOS will be there. Okay, K NMOS and K PMOS. For dynamic CMOS, you have how many NMOS? So how many NMOS? That means for pull down network, K inputs are there, and one more NMOS for clock is there. So K plus one NMOS are there, and if you see the PMOS, you have only one PMOS. That is a pull up network. Here you are giving the gated clock for PMOS. Okay, so this is PMOS. Okay, here this is NMOS and this is NMOS. Okay, NMOS. Okay, due to PMOS, so due to like K number of PMOS are there. Okay, PMOS due to PMOS, overall size is more. Overall size is more. For which one? Static CMOS. Okay, size is more. Overall size is more. And for a dynamic CMOS, due to less PMOS, you have only one PMOS, no? So due to less PMOS, less PMOS. Okay, so overall size is less. Overall size is less. Okay, overall size is less. And next, so due to more capacity, more PMOS, capacitance loading is more. Okay, due to more PMOS, more PMOS circuits are there, PMOS devices are there, so capacitance loading is more. Capacitance loading is more. capacitance loading is more. Okay, and here due to less CMOS, capacitance loading is less. Okay, due to less CMOS, less PMOS, capacitance, whatever the capacitance loading, capacitance loading, loading is less. Loading is less. Okay, and one more differences we'll see about the static CMOS and dynamic CMOS. Okay, uh, slower switching charge, static CMOS. So this is static CMOS, and this is dynamic CMOS, dynamic CMOS. Okay, so static CMOS and dynamic CMOS. Here's slower switching charge, lower switching charge, switching charge. Here faster switching charge. Why? Because only one PMOS is there, so that's why faster switching charge. Faster switching charge. Switching charge. Okay. Uh, Here no cascading issues. No cascading issues. Okay. Here cascading issues are there. Here in cascading some issues are there. In cascading, that means if you cascade two dynamic CMOS, so you will get some cascading issues. Okay. So you will get some cascading issues. In cascading some issues are there, okay, that we will discuss what are these cascading equation. um, Next, no need of pre-charge for operation. Okay, no need of pre-charge for operation. Here pre-charge of load CL is required for dynamic CMOS operation. Okay, pre-charge pre-charge of pre-charge of load capacitance, that is CL. Okay, is required is required is required for dynamic CMOS operation, for dynamic CMOS operation, CMOS operation. So pre-charge means what? In the operation I told you, see here. So that means first you need to charge the capacitor. Okay. So when clock equal to 0, first capacitor will charge from so charge to what? VDD. Okay. So this is nothing but pre-charge. Pre-charge means what? Pre-charge, in the pre-charge you are not getting any output. So in the evaluation only you are getting the output. Okay. So that means first what you need to do? You need to charge this capacitance. Okay. So when you are charging this capacitance during the pre-charge only, you can charge this capacitance. Okay. So depending on when clock equal to 0, then capacitance will charge. Okay. So pre-charge is required in the dynamic CMOS, where pre-charge is not required in the static CMOS. Okay. That is the meaning of this. So due to no need of pre-charge for this static CMOS operation, pre-charge is required in this static CMOS. Okay. So and next here if you see when output is 1, so one more disadvantage is there. When uh, so when output is 1, okay, when output is 1, there is no issues, there is no any issues. Okay. If when output is 1, okay, when output equal to 1, what happens? There are some issues. What are the input issues? Output stages in, so output will be there in high impedance state. Okay, output stays in high impedance state, high impedance state, impedance state. Okay, so impedance state, so there is a there is means there is so noise immunity is less. So noise immunity is less. So it is less prone to noise. Means it is noise immunity. So more noise will be added. Okay, it is more prone to noise. Okay, there is no change in leakage. No change in leakage. There is no change in leakage. Charge leakage creates problem. There is a charge leakage through the capacitance, load capacitance. So charge leakage creates problem, creates a problem. Okay, So this is the difference between static CMOS and dynamic CMOS. Yeah. Any doubt in this? that if you do the difference between comparison of static CMOS and dynamic CMOS, any doubt you have?
No, sir.
Okay. Yeah. So next, I told you, no, there are some disadvantages when you cascade this cascade this dynamic CMOS, no. So there is some disadvantage that I will tell you. Cascading, when you are cascading this dynamic CMOS, okay. So cascading, cascading of dynamic CMOS, okay. Cascading of dynamic CMOS, dynamic CMOS. So if you cascade dynamic CMOS, cascading is nothing but what? So this is cascading is suppose two inverters are there. So two inverters connected back to back. This is nothing but cascading. Okay. Here, so here you are giving 0. Here this is nothing but 1. Here you are getting same value. So that is nothing but it's acting as a buffer. No. Here you are giving 1. Here you are getting 0. Here you are getting 1. Okay. So I will draw this dynamic CMOS with cascading. So first this is VDD, and here I am drawing this is 1 PMOS I am giving to the gated clock. Okay. And next this one is pull down network as NMOS. Okay. Here you are giving input, here you are giving input. Okay. Input, and next this is clock. Okay. So here this is clock, and I am giving gated clock to the NMOS. Okay. So this is PMOS, I am giving the gated clock, and this is the NMOS, I am giving the input. Okay. Again here this is the NMOS, I am giving the gated clock, and this is nothing but ground. Okay. And output where I can take, here I can take output, here I can take, and this is the capacitor, load capacitor. This is load capacitor. Okay. So here what is, this is nothing but, let us take output 1. Okay. Output 1. Again this one is given to what, again this one is given to one more NMOS circuit, NMOS circuit, and here this is PMOS circuit. I am giving the gated clock, gated clock, and this is VDD, this is VDD, and next this is also for NMOS. I am giving you the gated clock. Okay. I am giving you the regulated clock, and this one is anyway ground. Okay. So this is PMOS and this is NMOS, and next this one is nothing but NMOS. Okay. So here I am taking output to, and this is, let us take the this load capacitance as CL1, and this is nothing but CL2. CL2. Okay. CL2. So I am drawing the timing diagram for this cascading dynamic CMOS. Okay. So I am drawing the timing diagram. Okay. So just, so here, so this is what let us take clock. Okay. This is clock. So here, so clock, so I am giving the clock value. So clock signal, first clock signal is 0, and next it is 1, it is 1. Next it is 0, it is 1. Okay. This is clock. So 0 1 0 1. Okay. And next, okay. So next I am drawing the input. Okay. Here I am giving the input. Okay. What is I input? 2 times I am giving 0, This is 0, 0, and 2 times I am giving 1. 2 times I am giving 1. So this is 1, this is 1. Okay, so this is my input. Okay, this is my input. So this is my input with respect to what? T. With respect to T. Okay, so if I want to draw this output, okay, if I want to draw this output, so here let us take this is output. Okay, this is output, out 1, out 1. Okay, so this is nothing but out 1, out 1. So this output, out 1. So here if you see, I'm drawing the out 1. So this is T. So I'm drawing the out 1. So let us take. Suppose what happens, I told you, no. So these are two states are there. One is nothing but prescale state. Next one is evaluation state. So what happens? So during this prescale state, what happens? This will be this. So capacitor will. So in the prescale state, we already evaluated. Okay. So this will be like. When the clock is 0, so when the clock is 0 and input is 0, so this will be on, and this will be input will be off. Okay, and input will be off, and this will be what? Clock is 0, so this is also off. Okay, so what happens? Output 1 will be charged through the capacitor, output will charge to what? VDD. This is nothing but VDD. So this is nothing but what? Prescale mode. So in the clock 0, you have prescale mode. When clock equal to 1, you have evaluation mode. Okay, you have the evaluation mode. So next, what happens when clock equal to clock equal to mm, uh, so when clock equal to 1, so what happens? This will be off state. This will be off state. This will be what? Input is 0. This is also off state. So input is 0, and input clock is 0. So this will be off state. Okay. So as this capacitor is charged to VDD, so there is a open circuit between this. Okay. Due to this open circuit, so here this is VDD, this is VDD, and when clock is 0, this will be on. No? So this will be when clock is 1, this will be off, and next this NMOS will be off, and this also NMOS will be off. So what happens? It will stay in VDD only, but due to this open circuit, it will be in which one? High impedance state. This line is nothing but high impedance state. Okay, and after that, when clock equal to in prescale, during prescale, so what happens? During this prescale, what happens here? When clock is 0, this will be on, and input is 1, this will be on, and clock is 0, this will be off. Okay, so again capacitor will charge to VDD. In the prescale mode, capacitor will charge to VDD. Okay, and what happens here, when clock is 1 and this one input is 1, so during this state, what happens is slowly capacitor will discharge. Slowly capacitor will discharge. Okay, so capacitor will discharge. Okay, so and during this state, okay, so during this state, so output 1 I want to evaluate. Okay, output 1, so output 2 I need to evaluate. Output 2, so this is prescale mode, and this is evaluation mode, and this is prescale mode, and this is evaluation. Okay, so what happens? So like you are getting the output 1 as what? VDD. No, you are getting the output as VDD. So when output 1 is VDD, this will be on, and input you are giving as so there is nowhere depending on input. This will be on, and clock is 0. This is on, and clock is 0. This is off. Okay, so due to this both are on, so here it will charge to what? VDD. In prescale mode, it will charge to VDD. Okay, and after that, when input is 0 and clock is 1, okay, so this will be off. Okay, this will be off, and this will be off, and next So here you are getting VDD only, no? Here you are getting VDD. So this will be on, and clock. If you see this clock, clock is 1. So this will be on. Okay. So this will be on means what? So there is a open circuit in this bit between the VDD and out one. So slowly it will discharge. Slowly it will discharge. Okay, so this is nothing but what you are getting at the evaluation mode, logic 1, logic 0. Okay, so that means whenever you are giving 0, you are getting what? Same value. So no problem, means here there is no problem. Here you are getting, when you are giving logic 0, you are getting same logic 0. Okay, the problem comes when it is input is 1. Okay, that problems comes when it is input 1. Okay, that we will analyze. Suppose again if you see, so when clock is 0, so this will be on, and here anyway this will be on only. You are getting VDD supply voltage, VDD voltage. So the V out equal to, you got VDD, no? So V out equal to VDD, V out 1 equal to VDD, and clock is 0, this will be off state. Okay, so in prescale mode again it will charge to what? VDD. Again it will charge to what? VDD. Okay, here this is VDD and this is VDD. Okay, but what happens here, that means here if you consider this case, this is nothing but 2 VTN, 2 times threshold voltage. Okay, so 2 times threshold voltage. Here when in the evaluation mode, when clock is 1, this will be off state, and this will be off state, and input this will be on state, and this one if you see, clock is 1, this will be on state. Okay, as this is off state, what happens here, this will capacitor will discharge. Okay, capacitor will discharge. So after this point, after V2 into VTN, again what happens, it will charge, it will charge. Okay, so this case, that means you are not getting whole output. Actually, if you are giving 1, you should get output as what? 1 only. So whole it should charge to whole VDD, but capacitor is discharging. After that it is charging. So only at half clock cycle you are getting this one. Okay, so whereas static CMOS, there is no, like you are giving 1, you are getting 1 only, but here capacitor is discharging, after that it is charging. Okay, so that means so here I can say that output is not grounded. Okay, output is not VDD. This case, in this case, output is not VDD, or output is not ground. Output is not ground. Okay, so here you will get the problem with when you cascade this dynamic CMOS. Okay, so during I told you, so in the disadvantages, there is a cascade issues there. Okay, cascade issue and race problem is there. So cascade issue is what? So when output is 1, there is no issue. Okay, output is 1, there is no issue. For static CMOS, okay, there is no issue. For dynamic CMOS, when output is 1, okay, output stay in what? High impedance state, and it is in a so it's a noise immune, and so in the cascade also there is no cascading issues in the static CMOS, but there are some issues in the cascading. What is that issue? We already analyzed with the timing diagram. So when it is this logic 1, okay, input is logic 1. So what happening, this capacitor is discharging. Okay, so till here what happens, capacitor will discharge after crossing this twice that of VTN. Again this will discharge. This point is nothing but either it is not VDD, either it is not ground. Okay, so either it is not VDD, either it is not ground. Okay, so this is one of the issue. Okay, to overcome that we need to go for domino logic CMOS. Okay, so I think it will take one more class. Okay, so Monday one more session is required. Okay, is it fine? Do you understood what are the issues in the cascade and So what is dynamic CMOS? So we already seen this. What is dynamic CMOS? What is the difference between static and dynamic CMOS with respect to the basic the general figure? Okay. So less number of PMOS will be used in the dynamic CMOS, and more number of PMOS will be used in the static CMOS as a pull-up. Okay. And we have seen the basic inverter for the dynamic CMOS. Okay. So there are two modes will be there, like pre-scale mode and evaluation mode. So pre-scale mode means you are not getting any output, just it will means we need to charge the load capacitor to VDD. For that, pre-scale mode will be operated at clock equal to 0. But in evaluation mode, you need to make clock equal to 1, and you are getting whatever the input, that output you are getting. For the inverter, you are giving 1 means here you see. So here you are giving 1, you are getting 0. Okay. In evaluation mode only you are getting the output. You are giving 0, you are getting logic 1. Okay. In prescale mode you will not get the output. Okay. So what are the disadvantages? What are the advantages? So VOH output high is VDD, output low is high, and ISS is 0. So dynamic CMOS logic has only one PMOS. Okay. So due to that, switching speed is more. Okay. So PMOS size is more than the NMOS size, no? So there in the static CMOS we are using KCMOS. Okay. Switching speed is less. Okay. Whereas in dynamic CMOS, switching speed is more. Okay. Circuit size is also small. Why? Because you are using only one CMOS, and it has less capacitance loading compared to static CMOS. Why? Because only one CMOS, one PMOS is there. So that's why only this thing. And disadvantage is nothing but when it is logic 1, it will go into high impedance state, that is more prone to noise. Okay. It will more affected with the noise. Okay. And it requires pre-charging. So before coming in, before, if you want the, if you are giving the input, it should be operated in pre-scale mode. Okay. Pre-charging, that is pre-scale mode or pre-charging. In the cascading, some issues are there. Okay. So that issues we already discussed. This is the comparison between static CMOS and dynamic CMOS. So if you see the static CMOS, NMOS and PMOS, you have K, NMOS and PMOS. But in dynamic CMOS, you have NMOS are K plus 1 and PMOS as 1. Okay. So the difference is you are giving gated clock for PMOS and gated clock for NMOS. Okay, only one PMOS is used. Size is more for static CMOS, size is less for dynamic CMOS. Okay, due to PMOS, capacitance loading is more. Due to PMOS, capacitance loading is less. Okay, and so more number of PMOS and NMOS are there. That's why slower switching charge for static CMOS, and dynamic CMOS faster switching will be there. In static CMOS, no cascading issues are there, and dynamic CMOS cascading issues are there. Okay. In static CMOS, no need of pre-charge. Here pre-charge is required to charge load capacitance. When output equal to 1, there is no issues in static CMOS, but output equal to 1, there are issues are there. So that is high impedance, that is a noise, immunity is less. Okay. And no charge leakage. Okay. There is no charge leakage. Here charge leakage is there. Okay. This is the difference. And what is the cascade problem? We already seen. So till you are giving 0, no problem. But here when you are giving 1, so either it is not going to ground or not going to VDD. You are not getting proper output in this case. Okay. So that is the main problem in the cascading dynamic CMOS. So to overcome that, so what we need to do? So what is the solution for this? What is the solution for this? You need to go for domino logic CMOS. Domino logic CMOS. Okay. You need to go for domino logic CMOS. One second. Yeah, domino logic CMOS. Or we can go for Nora logic. You can go for Nora logic. Okay. Uh, or you need to refining of clock. Refining of clock. Okay. So like this. So these are the solutions. Okay. How to overcome this cascading of dynamic CMOS? You need to go for